let's take a look at Tanjong Katong Girls Prelim 2022, Paper 1, Question 7. Find the coordinates of the stationary points of the curve y equals to x power 4 minus 8x power 3 plus 1 and determine the nature of each stationary point. Let's take a look at the question over here. I have highlighted there are two parts of this question. Let's take a look at task number 1 to find coordinates of the stationary point. So we all know that stationary point, the gradient will be 0. So I'm going to first find dy dx. dy dx is the gradient of the curve. Let's differentiate this. 4 bring to the front and reduce the power by 1. I have power 3 now. 3 times negative 8, that's going to give me negative 24. Reducing the power by 1, I get power 2. And last, we have a constant. Differentiate constant will be 0. So this is my dy dx step number 1. At stationary point, the gradient is going to be 0. So next step, I'm going to put 0 equals to 4x cubed minus 24x squared. So now I'm solving the equation. Take a look at this. I can factorize 4 and x squared out from this two. So next step, I'm going to factorize 4x squared. Factorizing 4x squared left me with x for the first term. Factorizing 4, I have a negative 6, so x squared is taken out. So I have x minus 6 in the bracket. Next, let's solve for x value. So to get 0 is either x equals to 0 or x equal to 6. Now, take a look at the question. They need to find coordinates, so which means I need the y coordinate. Let's put in 0 and 6 into the y expression above. So first one here, I'll have 0 power 4 minus 8, 0 power 3. And you can see, actually, I'll be getting this one as 1. Next, let's put 6 in. 6 power 4 minus 8, 6 power 3 plus 1. This will give me the answer over there, which is negative 4, 3, 1. Let me put them in coordinates form. I will have 0, 1, and also 6, negative 4, 3, 1. We have completed our task number 1. Task number 2, we're going to determine what is the nature of these points. So usually, I will look at the expression of dy dx over here. It's going to be easy to do a second derivative test first, okay? So I'm going to first write down d2y dx squared. Differentiating this again, 3 times 4, that's going to be a 12. Reducing power, so I get x squared. Okay, do 2 times negative 24, that will give me a negative 48. Reducing power by 1, I get x here. So this is my second derivative expression. So next step is to put x value in here, okay? I'm going to put 2 times. First, find d2y dx squared value by putting x as 0. So what happened is that I'll get 0. So to get a 0, it is inconclusive. Be a bit careful about this one here, inconclusive. Second, I'm going to put d2y dx squared. I'm going to insert 6 into here to find a value. Let me see what I have here. I have 144. This is good because I know it's positive. So what happened for the inconclusive part is that we need to do a first derivative test. So what happened here, I'm going to do a small tiny table over here by testing x value and write down what's the dy dx value. Meaning, look at this one is 0. I'm going to pick a point on the left and on the right of it and inserting into dy dx again. So let me insert negative 0.1 into dy dx and use my calculator. I'm going to write down the value here, which is negative 0.244. The center one is 0, which we already know the dy dx is going to be 0, so I don't have to insert again. And next, I'm going to insert a point on the right of it. So insert 0.1 over here. I'll be getting the answer as negative 0.236. So after this, let's observe the gradient. So this gradient is negative, means the graph is coming down. 0 is a flat one. Negative is coming down again. So if we connect this point, you can see that this is a point of inflection. So conclusion for x equals to 0, that's a point where the coordinate is 0, 1, is a point of inflection. So now let's go on to the other point where we have gotten d2y dx squared value. I'm going to rewrite a nice conclusion here. I'm going to tell them that d2y dx squared, when x I insert as 6, the value is positive, so I write more than 0. So now you can also draw a tiny shape here, more than 0 graph. This point is going to be minimum. Let me conclude this point here, where we have 6, negative 4, 3, 1 is a minimum point. Now, let me remind you again, when you have second derivative equals to 0, it's inconclusive because it can be a maximum and minimum as well. Okay, it does not necessarily needs to be a point of inflection. So whenever you get an inconclusive answer using second derivative test, make sure you do one more first derivative test to prove that whether it's a point of inflection or is it a maximum or is it a minimum point, okay?